Hi, welcome to our pre-calculus topic. Today is composition of a trigonometric function with the inverse of another trigonometric function, problem type 3. Type 3 here mostly about famous angles. We'll go through a few exercises here, and at the end I'll open the topic for students who are interested in mathematics and try to generalize the questions that we are looking at here. So let's go ahead. This is going to be short and sweet. So exercise number 1 is find the exact value of sine inverse of cosine of 5, 6. So the idea is that we reason our way to the answer as opposed to using calculator or giving any approximate answer. So it says write your answer in radians in terms of pi. So let's draw the unit circle that's going to help us to see what we are after here. You have some angle which is 5 pi 6. So we need to know where is 5 pi 6. 5 pi 6, we have looked at this thing quite a few times. 5 pi 6, pi 6 short of the pi. That's the angle. Well, this is the angle. What do we do with it? Calculate cosine of it. So you remember here is the cosine axis. So calculating the cosine of it means coming here. So by now this is cosine of 5 pi 6. Now you could look it up in your table and try to refresh your memory as to what this one was. Cosine of 5 pi 6 is minus radical 3 over 2. So you know it's minus because we are on the left side, and then we get the answer from the reference angle of this thing, which is pi over 6, or look it up on the table, or look it up on the unit circle. Okay, what next? So next question is, well, what is the sine inverse of minus radical 3 over 2? So of course we could go ahead and look this up in the table as well. So that would be legitimate. You just have an extensive table, you look up this number there, but let's see if we can also reason our way to the answer. So suppose this is this is cosine of 5 pi over 6, which is some number minus radical 3 over 2. I want to figure out the angle whose sine matches this. Well, do we remember what was the sine axis? So this is the sine axis. I want an angle whose sine becomes like this. So what I really want is to put same length on the sine axis. So since this is negative, I have to go down, and then figure out an angle in the appropriate range of sine inverse, which we said is in quadrant 1 and 4. So I want to go this direction. Is that right? I want to go in this direction and connect this to origin and find this angle. So again, you can look this up on your table and be done with it. So that would be one type of exercise. We learn what is cosine of 5 pi over 6, and then what's the sine inverse of that. That would be perfectly legitimate. The second approach here is trying to go step by step and understand what is involved. So we reason like this. We say, okay, now this triangle and this triangle are the same. This angle, the red angle was 5 pi 6. This is going to be pi 6. So this one also, this is also pi 6. So then what is left on for this angle? So well, in absolute value it's going to be pi third. since we are going in the clockwise direction, this is going to be minus pi third. So final answer becomes minus pi third. So once again, we can do this two ways. Find the cosine of pi 5 6 minus radical 3 over 2. Sine inverse of that from the table. You can say, well, this is minus pi third. But for all these questions, you can answer without the use of any calculator or any table. I'm going to come back to that and pose it as a question, as a extra or challenge question to students who are interested in mathematics. And hopefully some of you will take on the challenge. And in the next section, actually, we are going to have more of these type of questions. So that's going to be preparation for next. Here's another one. Arcsine of cosine of 7 pi 6. So again, here is one style of going through this thing. You can say, well, without using any pictures, 7 pi 6 we look it up, and it's going to be minus radical 3 over 2. And then we are asking what is the arcsine of that number. Is that right? So all of this gets replaced by minus radical 3 over 2. And the next level is what's the arcsine of that angle, that number. So that number is going to be minus pi third. Again, so minus pi third. Now suppose we want to arrive at this answer by drawing a picture. Let's see if we can spend a bit of time making the picture a bit more clean. So suppose here's my unit circle, and then this looks reasonable enough, maybe. Well, I guess it needs a steady hand, and I don't have one. Seven pi 6. 7 pi 6, slightly past pi, so sorry. So this is the angle 7 pi 6. First we calculate the cosine of this. So to find the cosine, we go to the cosine axis. So this is the cosine axis. Cosine of this is this green length, some negative number. Now we are asking what angle is it whose sine matches to this green. Well, sine axis is this vertical axis. This is the sine axis. We put the green on this axis. Then to find the angle, we go toward right. So here I go toward right and connect this thing to the origin. Now I make the observation that these two triangles will be, as you say in geometry, congruent or equal or something. So that means this angle same as this. Whatever it is, they are the same. Well, 7 pi 6, whatever is left here is pi 6. So this is also pi 6. Now you're coming below horizontal, so you have to start counting negative angles. So pi 6, its complement. Pi third, since you are going in this direction, is minus pi third. So the recipe we applied here is good for any angle. It doesn't have to be a famous angle. It doesn't have to be a familiar angle. We can apply it to any angle, and that's a question I'll be giving you at the end. But let's go ahead. Arc cosine of sine of 5 pi over 4. So to be fast, sine of 5 pi over 4. Do you know quickly what that is? So we start, here's the angle, here we are applying sine to it. Do we know quickly what that is? Well, minus radical 2 over 2. Okay, then what is the arc cosine of minus radical 2 over 2? What angle is it whose cosine is minus radical 2 over 2? Again, the issue is how quickly you come up with the answer. Of course, we can all go look it up. There are all these search engines, and there's your table, and there's your notebook, and all of that, and you want to be able to actually find these things and know how to find that. But to keep a conversation going at a regular speed, these things need to be second nature to us, so that later on when you go to calculus and so on, if this issue comes up, you can answer quickly as opposed to just look it up, because the act of looking up breaks the conversation and just makes it that much longer. So try it at several layers and push yourself to having a visual impression of these things so that you can quickly answer it. Now let me go ahead and answer also by drawing. The advantage of drawing is that, the advantage of drawing is we can answer this question even if the angles were not recognizable at some famous angle. It doesn't have to be always about some multiples of pi over 4 or pi over 3 or pi over 6 or something. Similar questions can be answered with any kind of angle. So I can give an arbitrary angle here and ask the same question. But visually what's happening here, so we have angle of 5 pi over 4. First item on the agenda, do we know where that is? So we have to quickly come up with the location of this angle. So this is 5 pi over 4. Next, do we know how do we measure sine? To measure sine, we go to sine axis. This is the sine axis. Well, what is it that we have? What we have is, this is the sine of this angle, this right angle here, this is the sine of it. Now, next question, do we understand what this means? Arc cosine. Arc cosine, we have to recognize this is the cosine axis. To find the angle, we take our number, lay it on the cosine axis. This is negative number, so I have to go negative direction. Then, to find the angle, I have to go up. So I go up. Final angle, you connect this thing to the origin, and the angle you're after is this. Well, I hope that everybody is convinced that this is pi over 4, this is pi over 4, and what is left here is 3 pi over 4. So the answer is 3 pi over 4. Let's go take a look at, this looks like something we already did. Well, this is in reverse order. Cosine inverse of sine of 7 pi 6. So again, sine of 7 pi 6 is pi 6 after pi, and the sine of it just turns out to be minus a half. Next question, so this is the angle, this is the sine of it, I calculated, level 3. What's the cosine inverse of the last number we got? So what is the cosine inverse of minus half? Do we remember what's cosine inverse of minus half? So make sure you have a table in your notebook where all of these things listed, and that you can find your table quickly, and then you get the answer 2 pi third. So the answer is 2 pi third. How do we do this thing on a picture? So again, we draw a circle. So let me quickly draw this cosine axis and sine axis. Angle is 7 pi 6. Where is 7 pi 6? 7 pi 6. Slightly more than pi, by pi 6. So 7 pi 6 somewhere here. This is the angle. How do we calculate the sine of it? We go to the sine axis. So this is to go to the sine axis. What is it that we have? Is this? This is the sine of 7 pi 6. It's a half, and it's going down, so it's minus a half. I want the arc cosine, meaning I take this thing and put it on the cosine axis. So I'm going to go this way. Then I go up, and this is the angle. This is the angle we are after. Well, however you want to match your angles. This is 60 degrees, this is 60 degrees, and what's left 120 degrees, or in radians is 2 pi third. So this is pi third, this is pi third. So this is pi third, this is pi third, and what's left is 2 pi third here. Okay. Sine of arc cosine of 1/2. So what is the arc cosine of 1/2? What's an angle whose cosine is a half? Well, that's pi third. So you notice we go from the interior, and layer by layer we build outside. So opposite of a, you say an onion, you start from the last layer and then works to the next one and then the next one. In math functions, the way our notation is used, this is your starting point, this is the next, this is the next, that's how you go. So at this was 1/2, at that level is pi third. By time we come here, we get pi third. Next, you're asking what is the sine of pi third? So that is going to be radical 3/2. That's the meaning of this problem. And cosine of tangent inverse of 1. Well, what is tangent inverse of 1? Tangent inverse of 1, the angle whose tangent is 1 is pi/4. And now we are asking what is cosine of pi/4? Well, cosine of pi/4 is radical 2/2. Did I answer this one? Sorry. Radical 3/2. And this one, radical 2/2. Do we have another one? Cosine of tangent inverse of radical 3. So tangent inverse of radical 3. You notice all of these are famous values. Angle whose tangent is radical 3. That's pi third. And what's the cosine of pi third? Cosine of pi third is 1/2. So we are learning how to do composition of functions. We are learning how to do this thing with trig functions. We are learning how to handle situation where some of these things are an inverse trig function. These are the things we practiced here. Okay, now in preparation for next lecture, and also just to give something to students who are serious about mathematics and want to go down in that direction or interested, let me just pose some questions for you, and hope that some of you will take this thing on Again, it's just a matter of interest. Some people are interested in one thing, some people are interested in another one. So some of you might be in a garage and dismantling an engine and putting it back together. That's one kind of interest. Somebody might be interested in painting, and somebody is in music, and so on. So here is another set of things some of you might be interested in. It's just entirely optional and some addition to this lecture. So again, it's not part of a grade or anything of that sort if you are interested. Okay, so main lecture is over. These are some additional material. So what is sine inverse of cosine of theta? For simplicity's sake, let's say theta is an angle that's given between 0 and 2 pi. If not, add or subtract multiples of 2 pi until it is so. Question is, what's the sine inverse of cosine of theta? And here is a hint. Try to show or convince yourself that it depends on which quadrant theta is. If theta is in quadrant 1 or 2, we are looking at pi half minus theta as the answer. And if you are in quadrant 3 or 4, the answer turns out to be theta minus 3 pi over 2. So this is type of a problem that's best approached by drawing those unit circles and reasoning yourself to the answer using just basic geometry and comparison of triangles. Similar question, what is cosine inverse of sine of theta? Again, subject to the same assumption that we have brought the theta into the first circle. Show that this is starts like that, pi half minus theta if you are in quadrant 1. If you are in quadrant 2 or 3, it turns out to be minus pi half plus theta. And in quadrant 4, it turns out to be 5 pi halves minus theta. Okay? And then, so these are similar to the questions that we had at the beginning, like sine inverse of cosine of 5 pi 6 and so on. Just check to see if you get the same answer. Then, let's see, we have a combination of trig with an inverse trig. Some of these things make good sense, some of them not so much. So here are some of the good examples. Cosine of tangent inverse of x. We are going to have questions like this in the next lecture, but try to see if you can convince yourself that this is the case. Again, by geometry, this is going to be the easiest. Sine of tangent inverse of x. X is any number. So it's x over radical 1 plus x squared. What else? Cosine of, for example, sine inverse of x. That's going to be radical 1 minus x squared. Similarly, sine of cosine inverse of x. That one also is radical 1 minus x squared. You look closely, you see these are all pieces that come up in the Pythagorean theorems, and for good reason they show up here. Again, tangent of sine inverse of x is x over radical 1 plus x squared. Sorry, my mistake. Let me correct this thing. Tangent of sine inverse of x, x over radical 1 minus x squared, and tangent of cosine inverse of x is also 1 minus x squared over x. Okay, just do plenty of these exercises until you can answer each of them under 20 seconds. Okay, the exercises that we had here, reasonable time for each of these things, 20 seconds to be prepared for calculus. Okay, let's move on. So I'll see you next time. Until then, good luck and God bless.